Hello everyone, welcome to my channel GVS Chem. In this chapter, let us discuss states of matter, intermolecular forces. Please subscribe to my channel, like, share and comment my videos. Intermolecular forces. Attractive or repulsive forces acting in between the particles. Here particles means atoms or molecules. If the forces exist in between atoms, they are referred as interatomic forces. If the forces exist in between molecules, they are referred as intermolecular forces. So the attractive or repulsive forces acting in between the particles of the substances are called interparticle forces. This we discussed the atoms. Forces in between atoms are called intratomic forces. Forces in between molecules are referred as intermolecular forces. Intermolecular forces affect the properties of the substance like melting point, boiling point, etc. Greater the magnitude of intermolecular forces, greater is the melting point and greater is the boiling point. Now let us discuss the types of intermolecular forces. Intermolecular forces are mainly two types. One is van der Waals forces and hydrogen bonding. Again, van der Waals forces are divided into different categories. That is, dispersion forces or London forces, dipole-dipole interactions, dipole-induced dipole interactions. See here, in this diagram, this is the neutral molecule. In the course of revolution of electrons around the nucleus, sometimes the electrons, that is all the negative charge comes to one side and automatically other side is referred as a positive charge. As electrons come to one side of the atom, it is negative charge, automatically the other side becomes a positive charge. So these are referred as, these positive and negative charges are called dipoles. So these dipoles are momentary. Momentary means they are not permanent. Because electrons revolve around the nucleus, the position of the dipole may change from time to time continuously. So the attractions developed between neutral atoms or molecules just due to the presence of mere presence are called dispersion forces, and of course they are also referred as London forces. See here in this diagram, it is clearly understood that the two atoms come closer. So negative charge comes to one side, automatically the other side becomes a positive charge. Since the other side becomes a positive charge, the adjacent side of the other atom becomes a negative charge. Therefore, in between this positive charge of this atom and negative charge of this atom, a temporary attractive force develops, and this temporary attractive force is referred as London forces or dispersion forces. Keep the point in mind, the London forces, they depend on the distance between them. If the distance is 500 picometer, then it is significant. If the molecules move away from each other, the attractive forces do not have any significance. London forces, though they are very small or their magnitude is very small, they are important during the forces are important during the distances of 500 picometer, and the magnitude depends on the ability of the polarization. This is just now we discussed. London forces increase with increase in molecular size or molar mass. If the molecules are bigger, the London forces are larger. Number of electrons, that is as the atomic number increases, number of electrons increase. If the number of electrons increase, London forces increase. Surface area of the molecule. So if the surface area means larger the molecule, surface area is larger. Therefore, London forces also larger. London forces affect the boiling points. Though London forces are smaller, London forces affect the boiling points. Greater the London forces, greater is the boiling point. Now let us see the next one is dipole-dipole interactions. In polar molecule means a molecule in which the covalent bond is shared unequally between the atoms due to the difference in electronegativity. So in polar molecules, the difference in electronegativity between the bonded atoms make them dipoles with partial opposite charges. So here, let us take an example, hydrogen chloride. In hydrogen chloride, chlorine is more electronegative and hydrogen is less electronegative. Due to this, the bonded pair is pulled towards the chlorine atom since chlorine is more electronegative. Therefore, a partially negative charge establishes on chlorine atom. Automatically, hydrogen develops a partially positive charge. So, this positive charge and negative charges, they are referred as dipoles. Negative dipole of one molecule and positive dipole of another molecule, they attract each other. Hence, these attractions are referred as dipole-dipole interactions. So, the dipole moment means it is the product of magnitude of dipoles on atom and the distance between them. So, whatever be the magnitude of the dipole on any atom, say here, whatever be the positive magnitude is there, the positive charge is there, the same amount of negative charge is present on negative dipole. So, the product of magnitude of the dipole and distance between them is referred as a dipole moment. DD forces, that is dipole-dipole forces, are greater if the dipole moment is greater. If the distances among the molecules increase, dipole-dipole interactions decrease. So the dipole-dipole interactions is inversely proportional to the cube of the distance between them. Whereas London forces, the magnitude of London forces are inversely proportional to the distance to the power 6 times. Now let us see dipole-induced dipole interactions. A permanent dipole of the polar molecule induces the dipole in the electrically neutral molecule by deforming or polarizing its electron cloud, and these attractions are referred as dipole-induced dipole forces. See here, in this molecule, this is permanent dipoles are established here, whereas this is a neutral molecule. Because of the presence of a permanent dipole molecule, here in this neutral molecule, dipoles are induced due to the presence of this permanent dipoles. So in between, an attractive force develops, and these interactions or attractive forces are referred as dipole-induced dipole interactions. So interaction energy in between, that is dipole-induced dipole interactive energy, is proportional to 1 by r to the power 6 times, where r is the distance between them. The best example is water iodine, means iodine is dissolved in water, therefore this is iodine water. We know that water is a universal solvent. So water is a polar solvent. How it is? This is hydrogen, O hydrogen. So here oxygen has a partially negative charge, whereas hydrogen has a partially positive charge. So this is water has a permanent dipoles. Permanent dipoles, whereas here iodine molecule I-I, it has a covalent bond. This is non-polar covalent bond. Because of the dipoles, here temporarily partially positive charge establishes. Therefore dipole is induced in iodine molecule. So in between this permanent dipole and induced dipole, an attractive force develops, and this is referred as a dipole-induced dipole interactions. Now let us see hydrogen bond. It is a special case of dipole-dipole interactions. A bond formed between the partially positively charged hydrogen atom of one molecule and the partially negatively charged atom of other molecule is referred as a hydrogen bond. Now let us try to understand this with an example. The best example is water, H2O. Water, it is in this way water molecule. So oxygen is more electronegative, therefore it has a partially negative charge, whereas hydrogens have a partially positive charges. Other water molecule is here. So in every water molecule, partial and positive charges are developed on oxygen atoms and hydrogen atoms respectively. So this is another water molecule, negative charge and positive charge. So in between this partially negatively charged electronegative atom of one molecule and partially positively charged hydrogen atom of another molecule, a bond establishes, and this bond is known as a H bond or hydrogen bond. Right. So in the chapter chemical bonding, we discussed about this hydrogen bond thoroughly, and hydrogen bond is of two types. One is intermolecular and another one is intramolecular. And of course, in water molecule, the hydrogen bond establishes is referred as nothing but intermolecular hydrogen bond. So because of this hydrogen bond, intermolecular hydrogen bond, water, boiling point of water is 100 degrees centigrade. Because of the presence of hydrogen bond, all the water molecules associate with each other. Therefore, water is referred as associated liquid. And water can dissolve many substances in it, and it is nothing but solvent. Hence, finally, we can say that water is a universal solvent. So, till now, we discussed London forces. London forces are also referred as dispersion forces. And the second one is dipole interactions. The third one is dipole induced dipole interactions. And the other one is hydrogen bond. Now, among these three, that is London forces, dispersion forces, and dipole interactions, dipole induced dipole interactions, the order of strength of these interactions are: London forces are less stronger than dipole induced dipole. Dipole induced dipole is less stronger than dipole interactions. So this is the order of strength of interactive forces. Now, based on these interactive forces, let us discuss some questions. The dipole, the first one here is the dipole forces are stronger than dash and weaker than dash. See, the first here the order of the forces is important. So the first option is dipole induced dipole interactions. Dipole induced dipole interactions are less stronger than. So this is not correct. And London forces. The second option is dipole interactions are stronger than London forces. And ion interactions. Ion interactions means it is nothing but ionic bond. Therefore, the correct option is second one. And the next one is, what are the forces of attraction and repulsion between interacting molecules? The first one is attractive forces. So first one is not correct. Repulsive forces, this is also not correct. And the intermolecular forces means between the atoms. So this is the third option is the correct option. An example of ion interaction. Ion interaction means, see here, NaCl. This is Na plus Cl minus. So here ions are there, therefore it is an example of ion interactive forces. Whereas a water molecule is a polar covalent bond. Therefore it is an example of a hydrogen bond. Neon. So this is London forces. And here this is dipole. Water molecule has a dipole, whereas iodine molecule does not have dipole. Therefore it is a dipole induced dipole interactions. So the correct option for the third question is A. In which of the following strong forces exist? Strong forces. See, options are HCl, CH4 and helium, water and HCl. See here in HCl, CH4, CH4 is neutral molecule and hydrogen has a dipole. Therefore, this is a dipole induced dipole interactions. Dipole induced dipole. Whereas in helium, London forces exist. Whereas here, hydrogen bond. Hydrogen bond. Of course, here also hydrogen bond exists. But so the first two are not the options, correct options. So among C and D, we have to finalize the correct option. Water is a liquid at room temperature, whereas a hydrogen chloride is a gas at room temperature. That means, though hydrogen bond is present in between these two, the H bond in HCl is less stronger than H bond in water. Therefore, the correct option, in which of the following strong forces exist? In water strong forces exist. And the next question is, hydrogen bond plays a vital role in determining the properties like a boiling point. Which of the following is not an example of a hydrogen bond? Water. Water has a hydrogen bond. Just now we discussed carboxylic acid. Carboxylic acid means RCOOH. So carboxylic acids also have a hydrogen bond. Because of this hydrogen bond and carboxylic acids, they exist as a dimers. Alcohols also exist a hydrogen bond, whereas a methane, it is a non-polar covalent bond. Non-polar covalent bond. So in non-polar covalent bond, hydrogen bond does not exist. Therefore, the molecule in which hydrogen bond not present is methane. Please subscribe my channel, share and like my videos. Thank you.